The chi-square test of association is basically when you try to prove that there is association between the two variables. But in this case, again, all these chi-square, you do it for the categorical variable. So this session, again, we will undergo this session. First, we'll learn the basic concepts. Then we'll see what are the research questions which are for which we answer, to answer which we need the chi-square test of association. What are the assumptions and hypotheses for chi-square test of association? What are the commands and how do we interpret those commands? And at the last, the summary of all the commands. So like if the research question is, if I want to know that there is any association between gender and diabetes status, like gender can be categorized as male and female, and the diabetes as a presence or absence of diabetes. In that case, let's see this hypothetical example. In this case, okay, count, I will again, so should I explain the count again once again? Okay, if it is that the case, then I'll go back to this. Maybe I will refresh this. So I will go to this frequency, this goodness of fit. In this goodness of fit, the first was the severity. So disease severity I have entered here. If you don't write anything here, it will take the equal proportion. But it is given to me in the question that 70% are asymptomatic. So I'll enter 70% here, 20% are moderate, and 10% are severe. So 10% you have entered this, and now if you check this expected count. So basically this, how do we take out the expected count? So your expected count we calculate on the basis of the proportion which has been entered here. So this 126, it is out of that, if you take 70%, this 126 will be the expected total number. That means 180, 70% of 180, 20% of 180, and 10% of 180. This is the expected number. Means against that known proportion, if you use that proportion for the total number, then whatever number comes here, that is your expected. So this is the expected. If you calculate 180, 70% of 180, see how much it comes? Because you have asked me to explain this expected also. I'll show you here in the calculator as well. So can you see it here? So like I may, so total number of cases are 180. So if you take 180 multiplied by 0.70, because 70%. So it is 126. So can you see the expected proportion in this case is 126, the count, this one. Let me show you. This is 126. So this expected, okay, now you got it. So all of you, is it clear that 20% is 180 ka 20% is 36 and 180, 10% is 18. So this is the expected count. But the observed is different. It is 21, it is 35, and it is 124. So on the basis of that, okay, yeah, you can see, I think previously it was not getting refreshed. That's why Venkatesh is right that it was taking 18. So in this case, all the three cells, if you see the expected, all the three cells are having cell count, expected cell count more than 5. In this case, 126, 36, and 18. So none of the assumption is violated, and the value of chi-square, but again, the value of chi-square, it was not significant here. You can see it is 0.756. Now coming to the second example. So second example, was it clear? Should I repeat that example once again, or you got it? One of you can type in the chat box. Clear. Okay, then I am leaving it. Thank you. And thank you, Venkatesh. So I'm going back to chi-square test of association. So I was here. So you assume these all samples to be a part of your study sample. I have conducted a study and I have asked only 2 questions from these study subjects, like what is your gender and are you a diabetic or not? So I have collected the data and I have made a contingency table. Now, what is this contingency table? It is a cross table, which is also known as the cross tab or a two-way table. It's an arrangement where the data is classified according to the two categorical variable. So there is a 2 by 2 contingency table. In this case, you have got 2 categories of each of these variable, diabetes as no and yes, and male as gender as a male and female. So this is the 2 by 2 contingency table. If you take one category having 3 levels, like in this case, you can see BMI has got 3 levels. So that will be like, and the diabetes 2. So it will be a 3 by 2 category. And this is known as the 3 by 2 contingency table. So just ponder on this slide for a few seconds. You can see there are 3 case scenarios. And now tell me, even if you don't apply any statistical test, can you say that in which case there will be association, there is a slight possibility, or there is no possibility at all? So I'll see in the chat box what you people are writing. So Neeraj is writing significant association with in 3. Okay. 3 possible. What about 1 and 2? Nidhi is also writing 3 significant. 2 slight possibility. Viral is writing. Okay. 1 not possible. Yes. So you are right. Santosh is writing 2 and 3. So yes, you are right. If you see this, first is there it seems that there is no association. Second, there can be some possibility. And third, it seems that there is a definite possibility. So there are, in first case, no association, some and there is a strong association. So what are the research questions? So the first research question could be, is there any relationship between the BMI categories, where I have categorized the BMI having normal, overweight and obese, and history of cardiovascular disease status, like present or absent. The second research question could be association between the surgical technique X and surgical technique Y, and occurrence of infection is having 2 categories. The third could be the association between the quality of sleep. Again, the quality of sleep is having 2 categories, good versus poor, and versus the academic performance, that is also good versus poor. So in all these research questions, what have you observed? That there is a categorical variable. Both the variables are categorical in nature, and we are trying to look for any association between those categorical variables. So the appropriate statistical test for such research question is the chi-square test of association, which is also known as the chi-square test of independence. Now we call it as a chi-square test of independence because in hypothesis, the null hypothesis, what we form, we say that the 2 variables are independent of each other. So that's why if we refute this, we say that there is association. Both of these are opposite to each other. That's why we have got 2 names for this test, which is known as the chi-square test of association or chi-square test of independence. But again, like correlation, we can say that the presence of association here, it doesn't say that it is causal in nature. To say that one variable is causal for the other, you need to satisfy the Hill's criteria for causality. So the underlying assumptions for this chi-square test is that there should be 2 categorical variables. There can be 2 or more levels for each of these categorical variables was having more than 2 categories. And there should be independence of observation. We have seen what is independence of observation means. That means if you have counted one individual, maybe if he's a diabetes, you cannot count that person again in non-diabetic. So there will be separate people in each of these 2 groups. That is known by the independence of observation. And it should have relatively large sample size. That is, we say that large sample size because then the expected cell frequency will be more than 5. So Neeraj is asking the difference between the association And correlation here is only based on the nature of data. Yes, the nature of variable. So in one case here, you can see that the both variables are categorical in nature. Whereas there in case of a correlation, the both variables were continuous in nature. Otherwise, both are test of association. Yes, there is more to it. More is only in that sense. In both the case, we have got a effect size. The correlation, the effect size is the value of correlation coefficient itself. Whereas in chi-square, you will see that there is a phi and Kramer V value, which tells us about the effect size, whether it is a strong, medium, or a weak association. So definitely both these tests, correlation and chi-square of test of association, it tests the association, none test the causality, and it's only the nature of variable which is different in both these cases. But there is a difference in case of a chi-square. There should be independence of observation, and I mean, obviously the assumptions are different for both these sets depending on the nature of the data. Did you get your answer, Neeraj? Or do you want something more? Okay. So now independence of observation, we have done this, but again, just to reiterate this, that there is no relationship between the subjects in each group. We also call this as it is the opposite of paired value. So we will see in the Mac-Niemer test and paired t-test that we define something called as the paired value. So whenever there is a relationship between the variables, like if you design a research question, you take 10 couples and you keep all females in one group and all males in one group, and then study the presence or absence of diabetes. Will that be an independence of observation? Please type yes or no. So question I'll repeat once again. In the same case which I have shown you, like I have asked two questions. What is your gender? And what is your, maybe the status of diabetes? Or you can ask, so in this case, can I take 10 couples and ask regarding their gender and maybe the diabetes status? Or if I ask the status of contraceptive use, can I take 10 couples, have 10 females in one group, 10 male in one group, and may ask regarding the uses of maybe one or the other? But in male and female, the contraceptive will not be a good example because the two cannot have the same sort of contraceptives. So that will not be perfect, maybe diabetes. So can we say that the independence of observation hypothesis, I mean assumption, is met here? Pradeep is writing yes. Okay, anybody else? So ideally the answer will be no, because they are related to each other. Husband and wife, they are related to each other in many things. So that's why you cannot keep all male in one group and all female in one group and say that no, these many are diabetic and these many are not. Maybe the history of cardiovascular disease, because many diseases that are dependent on lifestyle. And if the two people are living together, then there is a observation will not be independent. That's why we say that the two person in each group should not be related to each other. Neither they should be husband and wife, nor they should be twins. There can be twin pair in one group, like one brother in one and the second in the other group. So yes, Neeraj, that is right. We cannot test this assumption through statistics. Through SPSS or through JAMOVI, there is no objective way to test this. This is a study design issue. So when you are recruiting the individual, then you have to take care of these things. So this is a study design issue. This you cannot check over the JAMOVI or SPSS, right? This is a study design issue, and you should ensure this while you are designing the study. You should ensure that you have used this independence of observation concept while you are recruiting the individuals. Is that right to all of you? Or should I repeat this concept once again, or is it clear? One of you can say yes or no. Pradeep is writing okay, but I cannot see anything now. Again, Pradeep is writing yes. Neeraj is also writing yes. Okay, then I can take 2 yes as a proxy yes for everyone. So the relatively large sample size, why we say relatively large sample size? Because, if the sample size is large, then at least we will expect that the expected cell frequency in each cell is more than 5. If the sample size is very less, like if you have got 30 samples, and if you're making 2 by 2 table, there are high chances that in one or the two cell, the number will be less. Maybe many times we have seen PG students coming with a 2 by 2 table, or they make 4 by 4 table. So in 4 by 4 table, if the sample size is very less, in each cell, the number will be very less. So the expected will definitely be less. So we always advocate that you should have a large sample size. If not, then you can club the categories that we will see. That if 4 by 4 table is showing a very small number, you can club the category and you can make 2 by 2 table. Because this is one of the assumption that the expected cell frequency should be at least 5 for the majority of the cell. Now, what is the null hypothesis? So null hypothesis states that there is no relationship between the variables, whereas the alternative hypothesis states that there is a relationship between the variables. So now the concept of expected frequency, although I have shown it, so if you take the null hypothesis, like you say that there is no relationship, so you take that a proportion and you define the count in each cell as if the null hypothesis is true. That means there is no association. So if the two variables are independent of each other, then the expected count and the observed count, the both will be the same if the two variables are independent of each other. So that's the concept of expected frequency in a cell. And statistically, we define it like expected frequency. All of you know that it is the row total into column total. In denominator, we take the sum total. But ideally, we don't do it. The system or the software calculates it. But if you want to know it statistically, this is the formula to calculate the this expected cell frequency, that it is the row total multiplied by column total divided by sum total. Now I was talking about the effect size. Now what is this effect size? So if the chi-square value is significant, it says that it is 0.01. Now what is the strength of this association? Because in Pearson, by the value of Pearson correlation coefficient, you can say that the correlation is strong, medium, or small. But with the chi-square p-value, that p-value tells you regarding the statistical significance, whereas the effect size tells you regarding the clinical significance. Because if you increase the sample size very much, then definitely, even if something is clinically not significant, it will become significant. But the statistical significance has some value in clinical significance? So that answer we can give by the effect size. So effect size tells you how clinical that significant statistical significance is. That means effect size tells you clinically how should we go about it. So if in the chi-square, the value of phi and Kramer V. So here you will say the value of Kramer V because phi is there only for 2 by 2 table. Kramer V can be there for both 2 by 2, 2 by 3 and 2 by n by c table. So if the value of this Kramer V is 0.1, we call it as a small effect size. If the value of this strength of association or this Kramer V is 0.3, we call it as a medium. And if it is 0.5, we call it as a large. Now let's see how to do this. So this is the data set and maybe I will show you the question. So this was chi-square test of association. So this is the first question. I told that this is the record of 180 patients and I want to know what are the factors associated with the oxygen requirement, in what cases. So my dependent variable in all these cases are oxygen requirement, and I want to see it against other variables like maybe gender, whether the oxygen requirement was more in male patients or in female patients. Similarly, oxygen requirement was more when the person was smoker or when the person was non-smoker. Similarly with the age group. So how will I do that? I will go here, you can see, and then again, there is an option of frequency. So in this frequency, initially we used this chi-square test of goodness of fit. Now we will use this contingency table. So this contingency table or 2 by 2 table, this is the independent sample. I click this. Now you can see there is a row and there is a column. So remember, the dependent variable, we shift it in the column, and the independent variable, we shift it in the rows. So in this case, my dependent variable is the oxygen requirement, because I have to check the oxygen requirement with all the other variables. Like in the first case, maybe the gender. So what I'll do, in the column, I will shift the oxygen requirement. So this is the oxygen, yes or no. And in the rows, I will shift the gender of the patient. So you may shift the gender here. And then in statistics, you click this chi-square. This is default. It is already clicked. And then this, you apply this continuity correction and Fisher exact when the expected cell frequency is less than 5. So in this case, you can see the expected cell frequency. So maybe in the statistics, if you click in the statistics and the cells, in cells, you can see the expected count. I can again click this along with this observed count. I may click the expected count. So you can see here, expected count in each cell, it is more than 5. So this is 36.7 and 13.3, the expected count. We never report expected count, just for demonstration purpose I am showing you. Otherwise, you don't do this expected count. So this, you can see all the expected cell count, it is more than 5 in each cell. And then you can see the value of chi-square with degree of freedom 1, it is 0.04. So it is significant. And you can see, like, you want a proportion also. So you want row wise percentages. So I have clicked that. Again, in these cells, I can remove this expected count. So now how will you write the interpretation? You can see here that the females, the oxygen requirement in females was 16%, where oxygen requirement in males was 30.8%. So the oxygen requirement in males, it was 14%, approximately 14% more than the females. So you can focus on these two values, and you can write that there was this chi-square value with degree of freedom 1, it was significant. And then you can write in this case, the phi and Kramer way. So I think I have not clicked that. So this, I think it comes. Yes, in nominal here you can see there is a phi and Kramer way. So this you can see that both these phi and Kramer V value, that is same for 2 by 2 table, it is 0.15. So it says that it is of moderate effect size, because till 0.1 we say that it is small, till 0.3 we say it as a moderate, and if it is 0.5 then we say it as a strong. So this is a moderate effect size, the value of phi and Kramer V. This was for 2 by 2 table. Now there are other examples. So other was like oxygen and oxygen requirement with the smoking status, smoker or not smoker. So you can, again, this will come here and you can have this smoker. So I have shifted this smoker here. So you can see any. So Neeraj is writing, we never use observed count for this condition. We always use observed count, Neeraj. Expected count for this, yes, for the expected Like for assumption, we never use observed count. If you mean by this question by that. For assumption, we always use the expected count, not the observed count. Because we say that the null hypothesis, what is the, yeah. So for that's why many a times we also like make a mistake whenever we see a 2 by 2 table, we say that the number is less than 5, but no, if you have to go by the expected cell count, it is not the observed count which is important. The assumption is that the, yes, many people do that, what you are writing in the chi-square. So it is the expected cell frequency, not the observed. You are right. For observed count, you don't test for any assumption. That is the expected count. That's why you should click the expected and you should check the expected count. And if it is more than 5, definitely you should write that all the cells were having expected cell frequency more than 5. That should be the one assumption which you should write in 2 by 2 table. Yes, you are right, Neeraj. So this is one. In this case, you can see here that the value in smoker and non-smoker. So how will I interpret it? You can again go and check for the observed and expected count as well. So this expected is like 89.5, 32.5, 42.5, and 15.5. So in all the cells, the expected cell count was more than 5. And then again, I will uncheck this because while you are giving it in the tabular format, you don't write expected. You only write the observed and the row-wise percentages. So you can see here that the people who were smokers, the oxygen requirement was less. And the people who were non-smoker, the oxygen requirement was more. So you can see here, we have to focus on this, these two. So 31.1% in non-smoker and 17.2% in the smoker. And then you can report the value of chi-square. It is significant. And you can report the value of phi and Kramer V. So that is there. So now coming to the third research question. So the third research question was, I have to check according to the age group. So maybe age category, I may enter here outcome. So total number of, so this is age group. So I'll enter this age group here. So it is 1, 2, and 3. And you can see here that this observed count, again, you can see 40 and 3. In this case, if you click this, you can see the expected cell count. So although the observed is 3, but expected cell count is 11.5 coefficient. Okay, I'm telling you how to interpret that. So can you see in this example, 3. And in this case also, although it is 10. So in this case, if you see this observed, what will you expect? That expected will be less, but expected here is, it is 11.47. In this case, so all these cases, the expected cell count is more than 5. So I may do, I'll go again back and I will uncheck this expected cell count and I'll see this. So I can see in the various age categories. So this was, I think, less than 30, 30 to 60 and more than 60. So you can see that the age, this requirement of oxygen was highest in the more than 60 years, followed by 30 to 60 and least in the less than 30 year of age group. The p-value was significant and the phi and Kramer V is of a moderate effect size. So now how to phrase the statement? So you can write it is of a moderate effect size and in the bracket you can write the value of Kramer V. I'll show the template where we have formed the result. It will be shared to you so that you can use this. Maybe this is the, or this was for the goodness of it. Maybe if you go by the chi-square. So this is the independent and dependent variable. So you can write here maybe the smoker. Here the dependent variable is the oxygen requirement. So present or absent. And in this case, you can write like smoking status. You can write in the footnote, you can write the chi-square value of test. And then again, a chi-square test of association was conducted between the smoking status and the oxygen requirement. All the expected cell frequencies were greater than 5. If not, then we have to click the Fisher exact test. And there was like a associated significant association or not, and there was a small or medium. So you can write like there was a small or medium or a strong association between the smoking status and the oxygen requirement, and in the bracket you can write the value of phi and Kramer V. Okay. So Sumit is writing, is there any concept of post hoc? Yes, Sumit, that is there. In the SPSS, there is a concept of adjusted residual and standardized residual. So in SPSS, you have this concept of post hoc, but in JAMOVI, this option is not there. So that's why maybe that post hoc is there whenever there is a 3/2 or n/c table. In 2/2, there is no concept of post hoc, but in case of a n/c table, there is a concept of post hoc, and that option is there in the chi-square, the SPSS. In this case, you can only look the percentages and you can decide like if it is larger or more, but again, there is no objective way to say that which of this cell is responsible for overall significance. That for that, I think this option, it might come later in the movie, but currently this option is not there. So how this phi and Kramer V strength of association is different from the univariate odds ratio? It is entirely different. Odds ratio tells you the in the univariate odds ratio. Okay. Yes. So am I audible now? So in univariate, whenever we apply that's odds ratio. So maybe odds ratio, what that says that you have got a disease. So the odds of exposure among the disease versus the odds of exposure among the non-diseased. So that value tells you regarding the amount of association or the strength of association. In this case, this strength is different from that strength, because for that you need a confidence interval also for the odds ratio. Even if the odds is 2 and if the confidence interval is less than 1, so you say that it is significance or not significant. That's odds ratio. Whereas in phi and Kramer V, it is more like the Pearson's correlation, which tells you the effect size, because odds ratio doesn't tells you the effect size. It's the maybe the is it audible now? Audible. Okay. Generally, what happens, usually when the value of chi-square is significant and all the assumptions are met, then you should comment on the phi and Kramer V. If the value of chi-square is not, I mean, that significance level is not significant, there is no point commenting on the phi and Kramer V. Okay, that is the prerequisite, that the chi-square is significant. Then only you should comment on the phi and Kramer V, because that this value of chi-square, it tells you the statistical significance. So once you get the statistical significance, then you will comment on the effect size or the clinical significance, right? If the statistical significance is not there, then there is no point conveying because that means that there is there may be some sample size issue, but it's of no value commenting this effect size without having a significant value. So generally it occurs when there is an inadequate sample size. In that case, it might happen that the chi-square will be non-significant, but this phi and Kramer V will be significant. So in case of, you can say that when there is a less sample size, there will be strong correlation. The value might go up till 0.7, but it is not significant. It might happen. So that is because of the sample size issue, usually. Is it okay for all of you? How to write the value and how to write the interpretation? Neeraj and all other people who are having any ambiguity in understanding this chi-square value of chi-square and the effect size. Okay. Then again, for the age group, so it depends number of variable, if it is 2 or more than 2, and depending on that, we may have the contingency table, and similarly, we may write our interpretation. So going back again to the JAMOVI interface, the another was 3x3 category, where the oxygen requirement with the disease severity. So the oxygen requirement, maybe the total number of comorbidities. So what I'll do, if I double click this, this will appear. So I'll shift this back, oxygen requirement and number of comorbidities. So this is the comorbidity 1, 2, and 3, means no comorbidity 1 to 2 and more than 2. And let's see the oxygen requirement. So the oxygen requirement, you can see here that it is, if it is 28.3 in the more than 2 comorbidity, it is 24.2 in 1 to 2, and it is 27.7 in no comorbidity. So you can see it is approximately same percentages. It is ranging from 24% to 28%, and therefore you can see here that value of this chi-square is also less, and p-value is not significant. And the Kramer V also, it is 0.04. So obviously, if it is not significant, there is no point telling the value of Kramer V or the effect size. But that is one. Again, if you want to calculate it with the disease severity, then you can shift this here, and you can have this disease severity in the rows. So again, you can see like asymptomatic, mild, moderate, and severe. So you can see here it is 21, 37, and 38. Again, it is p-value is not significant, and this phi and Kramer V, it is 0.165. And you can report this 2x2 table. Obviously, you can see the in the statistics, you can in this cell, you can click on this expected count. Whenever there is more than 2x2 table, you can click on this expected count. You can see it is 25, 9, 33, 90, 15, and 5. So you can see this severity is borderline. Although we say that 80% of the cells, it is not that each cell. In this case, in severe category, you can see it is the 5.6, the expected cell frequency, but it is still more than 5. It is not less than 5. And we say that the 80% of the cells, so it is if it is a 9x9, so 80% of 9x9 you can calculate, and maybe that much 7 or 6 point something. So those many cells should have expected cell count more than 5. So this was regarding the chi-square test of association. Any question in chi-square test of association? Then otherwise I'll go to the chi-square test of two proportion. Any one of you having any questions in this?